Hey everyone, in this video we're going to give you an introduction to detailed drawings. In this video I'm going to go over why we need detailed drawings, what these drawings would actually contain, and the rules behind drawing them. Before we begin, let's start talking about why we need detailed drawings in the first place. Now remember, the purpose of a project plan in the first place is that you would create a set of documents that you could pass on to anybody and they could read it and use those to create a faithful copy of your project. So a project plan consists of two sets of drawings. The first set is an assembly drawing, which we talked about in the video before. It also involves a series of detailed drawings, and the number of detailed drawings you would do depends on the number of parts you have. To better help you wrap your head around the difference between the two, let's give you a tangible example. On the left here is an assembly drawing of a box. In a quick glance, it tells you what the box looks like when it's fully assembled. And on the top right-hand corner, it has a parts list, which tells you the parts, the number of parts you need, their sizes, and where they fit into the project. While the assembly drawing is a fantastic overview, it still doesn't give you lots of information. For example, if you're wondering about this slot over here, it gives you really little information about the slot. It also gives you very little information about this black strip here, what's the size of that, and you're not even quite sure what's really happening down on the bottom over here. To be fair, that's not the purpose of the assembly drawing. If we wanted to know more information about, say, part C, the box bottom, we would actually have to go and look at our detailed drawings. So after your assembly drawing would be stapled three different drawings, three detailed drawings, one for each part. So if you wanted to know more information about the long side, you can go and look at the detailed drawing of part A. And if we look over here on part C, it gives us a whole bunch of information we wouldn't have known. For example, we couldn't even tell that there was a slot in the assembly drawing, but there is one, and we can see that through the detail drawing. It gives us more information about that black walnut strip. Apparently it's 1 inch wide, and it gives us more information about the slots. And if you take a moment and step back for a second, it makes sense as to why they're called what they're called. The assembly drawing is the project assembled. The detail drawing is each part in greater detail. In the video before in our series, I went over how to do an assembly drawing, and we created this drawing over here. Now again, for the detail drawings, because there are 5 different parts, 1, 2, 3, 4, 5, we would need 5 different detail drawings, 1 detail drawing per individual part. Yes, including the plug as well. Now, regardless of how many detailed drawings you need to draw, in the case of the project plans for my mini shelf, I would need to draw 5 different detail drawings. All of your detail drawings must maintain all 3 of these features. They must all be drawn orthographically. They must all use dimensions to show the reader about the size of each part. And it must also use dimensions to give the reader information about special features that might exist in your project. For example, angles, curves, holes, or slots. And it also needs to tell the reader where these special features are actually located in the wood itself. Again, regardless of how many detailed drawings you do, it's always arranged orthographically. If you forgot how to draw things orthographically, I recommend you check the very first video in the series. Also, all of your detailed drawings, at the very least, must use dimensions to tell the reader about the length, the width, and the thickness of each part. Before we move on, let's pause and talk about dimensions. How do you use dimensions to show the size of each part? Dimensioning is like a language. It follows a very strict set of rules that you can't really get creative with. So I apologize ahead of time. I didn't create these rules. I'm just here to pass them on to you. So let's look at some examples. The most common type of dimensioning is talking about linear distances. So jargon aside, suppose you wanted to tell the person the distance from here to here and how long that distance is. What you do is you start by drawing one straight vertical line called the extension line at the corner. And if I'm talking about the distance from here to here, draw the other extension line coming up from here, like this. Then write the measurement right in the middle of these two extension lines, like this. Now the next step is to draw the dimension lines. So these are extension lines. We're going to add the dimension lines from here to here, like this. And you finally finish off by drawing two little arrows on the corner. All of your dimensions must look like this. If you stopped at this step, it's wrong. It must have the little arrows capping off the two ends. Suppose you wanted to talk about the distance from this corner here all the way to this corner down here. If we followed the same rules that we did when we were dimensioning this length, we would get something that kind of looks like this. And to be honest, it doesn't look great. It's kind of messy, it gets squished, and when you add more complex shapes, you start to lose this dimension in a sea of other dimension. So this isn't recommended. You want to avoid this, and instead, you want a dimension like this. In this case, I've got my extension lines referring to these 2 points, but my arrows are pointed inward as opposed to outward. This is acceptable as well. And as you can see, it's a lot more clear, it's a lot neater, and a lot less crowded. The name of the game when you're drawing dimensioned plans is you want to make sure it's clear and it's neat for the person who's reading it. So when we're talking about dimensioning linear distances, there's 2 styles in which you can dimension. You can draw the dimensions like this, or if it's super crowded and super tight, you can do dimensions like this. Nothing else. You can't get creative about it. So I just want to show you this is a more complex shape, and you can see this is something that's properly dimensioned. For all of my long lines, I'm using this style of dimensioning, and for all of my skinny features, I'm using this style of dimensioning. Now for more complex shapes, dimensions can start to get a little bit more crowded. So for example, let's pretend I needed to dimension this shape here. So I would need to talk about this length from here to here, this length from here to here, and this length from here to here. One of the ways you can do that is called stacking your dimensions. To do that, start by dimensioning this point over here. Then you can go, okay, well then what's the distance from here to here? And you can add a dimension directly on top of it. So I'm saying from here to here it's 5. And then finally, I can stack one more dimension on top of the 5, like this. So now I'm saying from this point to this point, it's 9 squares. When you're stacking dimensions, the smallest number must always be closest to the picture. So that's 2, that's closest to the picture. And the largest number, 9, must be furthest away from the picture. It doesn't work if I put the 9 down here and the 2 up there. Another way that you can dimension this is by what we call chaining our dimension. So here you're saying the distance from here to here is 2, the distance from here to here is 3, and the distance from here to here is 4. Both of these are correct and both are valid. It's your own personal preference on how you want to dimension. You always want to go for the neater choice or the choice that's easiest to read. And of course, you can always do a hybrid or a mixture of the two. All of these dimensioning rules that I talked about just now will be super helpful when you're talking about the size of the part, mainly length, width, and thickness. But your detail drawings also need to tell the reader more stuff. The details drawings need to tell the reader about special features and their locations. So for example, if I needed someone to make this part for me, the detail drawing would need to give information about this slot here. How deep is it? How wide is it? It would need to tell me about the curve here. What's the radius of this curve? It needs to tell me about the 4 holes. What drill bit size do I need to drill the 4 holes? And where exactly do I place these holes? So let's start talking about how we can start to dimension weird features like holes or curves or angles. One of the most common things you'll need to dimension is holes. So to tell the person what size drill bit they need, they're going to need to know the diameter of the hole you need. So let's say I wanted someone to drill a 1-inch diameter hole. The way I would communicate that is to draw a bent arrow that points to the hole, much like this. Then you would draw a circle and strike a line through it, and that is shorthand for diameter. So when someone sees this, the circle with the strike through it is telling you they need a 1-inch diameter drill bit. Alternatively, you could actually just spell out the word diameter, but let's be honest, who's got time for that? Another thing you're most likely going to dimension are curves. So maybe I needed to run this on the belt sander. In this case, you would communicate it through radius. So much like the holes, if I want to tell people this had the radius of 2, start by drawing a bent arrow that points to the radius, much like this. Again, it has to be bent. Then write R2. So the R is short for radius, and then 2 inches. Of course, you can always spell radius, but it's much easier just to do the R. Another common thing you might need to dimension are angles. Let's say I wanted to tell someone that this angle is a 45-degree angle. You would begin by drawing the extension line from this point here, and then you would draw another extension line that's the same angle as the angle here, much like this. In the middle of these two lines, you're going to write the degrees, so 45 degrees. And much like a linear dimension, you would then draw the line and the arrows. So it would look something a lot like this. I would also mention there are other ways to dimension angles. So consider this weird shape here. You can always use the angle dimensions like I just showed you. In this example here, I'm telling the person to take a piece of wood, measure a 1/4 inch from this corner, and then cut a 45-degree angle starting here. And that's one way to do it, and it's completely acceptable. Alternatively, you can use linear dimensions. So let's unpack what this actually means. So you're telling the person that they're going to take a rectangular piece of wood, and then they're going to start by looking at the red dimensions. So from this corner here, they're going to move to the left 3/4 of an inch, and they're going to draw a dot. Then they're going to look at this blue dimension here, and they're going to travel from that corner down 3/4 and draw a dot. Then they can connect the lines, and that would theoretically give them the same 45-degree angle. These are two different ways of saying the same thing. They're both correct. The preference ultimately goes to what is most clear or what makes the most sense for the person who has to go and make it. Just to review, here are the 3 most common strange features that you would need to dimension. Holes are communicated in diameter, curves are communicated in radiuses, and angles are obviously communicated in degrees. Sometimes you come across a really, really weird feature like this. How are you going to dimension this? So one of the ways you could do this is start by drawing that bent arrow, and you can always just write a little note to the reader. In this particular case, this piece was made with the special router bit, so there's no need to dimension it. You would just tell the reader to go find or buy that specific router bit and put that shape into the piece of wood using that particular router bit. Now, we spent a great deal of time talking about how to dimension the size of stuff. We talked about how to dimension the length, the width, the thickness, the size of the hole, the size of the curve, the size of the angle. We even went over how to go and dimension the size of really weird features like this. But I want to go back to that hole example. Your detail drawings not only have to tell you the size of the hole, which it does over here, but it also needs to tell the reader the location of the feature. Where exactly do I drill the hole? If I have slots, where exactly do I put the slots? Where do I put the angles? These are important things the reader needs to know. To go about doing that, I would probably start by putting in dimensions like this. I'm saying that from the top left-hand corner to the center of the hole, it's 2 squares down. Now that I know how far down I go, I also need to know how far right I need to go. So I would add a dimension like this. So now I know from this corner, I need to go 2 to the right and 2 down. And that's where I put the center of my hole. And that hole is made with a 1-inch drill bit. So that drill bit point would rest at this coordinate here. And I want to give you another example using this diagram over here. So here I'm putting a square hole into a piece of wood. So fantastic. I know the size of the hole. It's 2 inches this way, 3 inches down. Great. But we also need to know where exactly to put the hole. And so as you can see here, I'm going from this corner. The top left-hand corner of the hole is 1 square to the right, and it's 1 square down. So not only do you need to show the size of the hole, but you need to show the location of that hole over there. The next rule is about clarity and ease of reading for the reader. All dimensions must be outside of the picture. So if you look at my example here, all the dimensions are neatly outside of it whenever possible. Here is the same drawing, but here I've violated that rule. It's hard to read and it's very confusing as you have lines crossing all over the place. So you definitely want to avoid drawing inside the picture. This is bad, this is good. And this is also acceptable because yes, I'm aware that there is that extension line that bleeds right into the picture there, but you need that extension line. You need to tell the reader what you are referring to. In this case, it's the center of the hole. So if you need to have an extension line kind of drip into the picture, that's acceptable. What you want to avoid is having your numbers, your dimension lines, your extension lines all jumbled into your view drawing like this. That's bad. Now, your last rule with dimensioning, give enough dimensions so that someone could create the part. And this we've been hammering home this whole time. So if I were to dimension this shape over here, we don't actually have enough dimensions to create this because we're not quite sure how far down this slot is and what's the distance of this part here. We're not quite sure. But there's also more to that rule. On the other end of the spectrum, you want to avoid repeating yourself. So over here, same shape, but way too many dimensions. So let's unpack that. The distance from here to here is 5. Awesome. It also tells you the distance from here to here is 3. Once we have that, we don't actually need this 2. Because yeah, obviously the distance from here to here is 5, because this is 5. The same thing can be noted over here. If I look at this distance here, that's 3 inches. Awesome. So then why am I saying it's 3 inches over here? Of course it's 3 inches. It's a rectangle. So that, again, is too many dimensions. So it's like the Goldilocks rule. On the left, not enough dimensions. On the right, too many dimensions. You've repeated yourself like crazy. Here, it's just perfect. Because I know that this whole distance is 5. I know that this slot is 3 squares this way. If I wanted to figure out what this slot was, I can just do algebra and subtract 5 by 3, giving me 2. I know that this height is 2 and the overall height is 3. If I wanted to know what this distance was, I could just use algebra and subtract 3 by 2, giving me 1. And seeing as I know that this distance from here to here is 3, this one also is 3. So that's just enough dimensions. In my opinion, following this rule is one of the hardest rules to follow when you're dimensioning. So here's one of the ways that I would wrap my head around this. In this example, here's a detailed drawing of this particular part, which is what it looks like in 3D. This is the front, this is the top, and this is the right view. And so when you're approaching this, you start by drawing it orthographically. And my advice to everybody is just load the entire detail drawing with all the dimensions you think you are going to need. So I went ahead and just brain dumped all of my dimensions. I know that there's going to be redundant or repetitive dimensions. Then you want to pause and proofread. So let's start by comparing the front view with the right view. Now I know that the distance from here to here is 3 squares. 1, 2, 3. So obviously when you look at it from the front, the height isn't going to change. 1, 2, 3. So I've got a redundant dimension and I can get rid of one of these 3's. I'm just going to get rid of that one. Next, let's go up and look at the top view over here. And I've got a cluster of dimensions and I'm going to see if they're all necessary. So what this is referring to is 1, 2, and 3. And so it's telling me that this distance is 3 squares. This lip here is 1 square, and the distance from the lip to this corner is 2. So this here is redundant. I've said the same thing in multiple ways. So I just need to get rid of one of these 3 dimensions. If I got rid of this one here, I can figure out exactly this distance by subtracting 3 with 2. 3 minus 2 is 1. I know this distance is 1. But you're not wrong if you got rid of this dimension over here. Because if you were ever asked, what's this total distance, you could just add 1 plus 2, and that would give you 3. And of course, you could just remove this dimension and use algebra to figure this one out. 3 minus 1 is 2. Now, hypothetically, let's take this 2 dimension and let's move it up over here like this. And by doing so, I've actually created a redundant dimension. Let me show you why. If you look at this dimension here, it's saying this point from here to here is 2 squares. It's referring to this distance here on the actual drawing. Now, if we look at this green dimension down here, saying this distance is 2, it's referring to this distance here. As you can see, the red dimension and the green dimension are pretty much talking about that same top there. So they're actually redundant, and you can actually get rid of one of these 2 dimensions. You can choose to get rid of the red one or the green one. I'm just going to get rid of the green one. Going back to our original sketch, this 2 dimension down here on the bottom is technically fine. It's not redundant because it's referring to this face over here. And we haven't actually spent any time talking about this face over here. Now, of course, if we dimension that 2 up there, it would be redundant, but this is the only time I'm talking about this shaded section over here, so it's fine. A part of the process of proofreading is that as you start to remove redundant dimensions, you might recognize that you're actually missing some crucial dimensions. So, for example, as I look on this view here, I want to draw your attention to this lip here. So the distance from this point here to this point here is 1 square. But if we look at what it's referring to on the front view, it doesn't indicate that the distance from here to here is 1 square. We have no idea. All the dimensions say is that from here to here is 2. You could argue that you could simply count the squares and say that that's 1 square, but I think that's a faulty assumption. Because what if this wasn't to scale? What if the distance from here to here was actually 7/8 of a square or 15/16 of a square? By adding the extra dimension down here, things are a little bit more clear. We can now see that the distance from here to this thick black line, it's 1 square, and the total distance from here to here is 2 squares. And again, you could simply use algebra to figure out this distance, which would be 1 square. To end off this video, I just want to mention you want to proofread your detail drawings. Every time you're done one, you want to proofread it and you want to run through this checklist. The first question you always want to ask yourself is, did you arrange this orthographically? Is the front, top, right view, are they located in the correct place? Do they line up? If there are hidden lines, did you put them in correctly? And do they appear in all 3 views? It's your basic orthographic stuff that you learned in your first 2 videos. The second thing you need to ask yourself is when you're talking about length, width, thickness, or linear dimensions, do your dimensions look like this or this? Do they have the little extension lines? Do they have the dimension lines? Do they have the arrow? And do they have the dimension in the middle? When you're talking about holes, arcs, and angles, are they correctly dimensioned? Do they look like these 3 pictures down here? On top of that, not only have you talked about the size of the holes, arcs, and angles, do your readers know where to put the holes and slots? So how far down and how far to the right do I put this hole? In my experience, this is the number 1 set of dimensions that lots of students forget to add. So make sure you've proofread that and checked this one out. Of course, are all of your dimensions outside the picture and not inside? And as I mentioned before, have you erased all of your duplicate dimensions in the same view or other views. Every time you're done a detail drawing, you want to just quickly run through this checklist to make sure that you've answered yes for every single one of them. This would be an example of one detail drawing for one particular part. This is what the part looks like in real life, and then this is how it's represented. It's shown orthographically with front, top, right view. You know the general size of things. It's 12.5 this way, 2 3/4 this way. You know the thickness. And it also gives you all the little information about the special features. Angles, the width of slot, the depth of slot, where to put the slot in relation to the top. Okay, thanks for watching. Now, in the next video in our series, you can watch me go back to the shelf that I was working on the assembly drawing, and I'll walk you through how I would start from a blank page all the way to a finished detailed drawing for one of the parts. If you felt that this video was enough, you can just go ahead and start your detail drawing. Thanks for watching.